Okay, what we've done up until now in terms of graphing nonlinear functions, we've basically taken a quadratic function, which of course takes the form f of x equals ax squared plus bx plus c. We've basically taken that form and graphed it in the following way. We've taken our Cartesian coordinate system, and what we've done is we've either used y equals 0 as our horizontal plane from which we're going to find our points of symmetry. Okay, so in other words, we have a function that looks like this. We find these points here by employing the quadratic formula and setting f of x equal to 0 to do that. And once we find those points of symmetry on some horizontal some horizontal plane, we will, or horizontal line, we will then simply take this distance, divide it by 2, and then either add it or subtract it from one of these 2 points in order to find, say, for instance, this highest point here. We've done that, or we have, when during times when the quadratic formula couldn't be used because for whatever for the reason that the function does not cross the actual x-axis. So for instance, we have a function that looks like this. We've embedded an artificial horizontal line, something like this, at y equals, 10 or something. And we've simply then taken the quadratic function and set it equal to 10. In other words, we've artificially moved the x-axis. Again, in order to find these points of symmetry, and from those 2 points of symmetry we can find that bottom or that peak of that function, and then we can rough sketch that function, of course along possibly with having a y-intercept and so forth. Okay, so that's kind of how we've done, how we've graphed nonlinear functions and quadratic functions in particular. What we're going to move into now is we are going to become more sophisticated in being able to locate different points on these graphs, a little bit more efficient ways of locating things like this peak or this trough by using calculus. We are also going to be able to tell what the shape of the function looks like, the quadratic function looks like, before we even get to graphing it. And that makes our graphing capabilities far more efficient than they used to be. Third, though, we're also going to start graphing cubic functions, and of course a cubic function would take the form, for instance, ax cubed plus bx squared plus cx plus d. Okay, so we are actually going to start graphing those as well in this section of our quantitative analysis course.